And I'm live. That is cool. Today is 10th of December 2025, Wednesday. And with that, let's just begin Advent of Code for the day. Yep. And yeah, we have three languages remaining. And it is a good thing that I like kind of know two of them, C++ and Python. Swift, no idea, but Swift is also high level, I think. So that is cool. And yep, we will spin this thing three times, and whatever the language is that this lands on the third spin will be the language for today. So spin number one, C++, cool. Spin number two, and three spin just for aesthetics. And spin number three, I guess Swift. Swift would be the thing that I would like to have, but we have Python. Okay, let's use Python for today. Hello. Yep, yesterday was it. Add D instead of C++, do in something you don't know. There were like 12 languages at the start, right? And most of them I didn't know. So, yep, do something you don't know. Yep, I did that. And add in the code. And today is Python. Okay, Python, and this is the question for today. Mm, okay, that is something. Shit, that is actually something. What is this? Okay. Yep, you said you do projects after AOC. Yep, project, and the thing that I want to make is chess. Do it in C first? No, I'll make chess in, I guess I'll use Next.js for it, even though Next.js got a bug vulnerability right now. But yeah, I'll do that in Next.js. Just across the hall, you find a large factory. Fortunately, the elves here have plenty of time to decorate. Unfortunately, it is because the factory machines are all offline and none of the elves can figure out the initialization procedure. The elves do have the manual for the machines, but the section detailing the initialization process was eaten by Shiba Inu. Okay, all that remains of the manual are some indicator light diagrams, button wiring schematics, and voltage requirements of each machine. Okay, for example, this thing. The manual describes one machine per line. Each line contains a single indicator light diagram. Indicator light diagram. This is an indicator light diagram, and one or more wiring schematics in parentheses. One or more wiring schematics and voltage requirement. These are voltage requirements. These are lights, light indicator diagrams, and button schematics, whatever that means. To start a machine, its indicator lights must match those shown in the diagram. Its indicator lights must show what is shown in the diagram, must match, where this means off and this means on. The machine has the number of indicator lights shown, but its indicator lights are all initially off. So an indicator light diagram like this means that the machine has four indicator lights which are initially off, and the goal is to simultaneously configure the first light to be off and the second to be on, the third to be on, and the fourth to be on. Okay, you can toggle the state of indicator lights by pushing one of the listed buttons. Each button lists which indicator light it toggles, where 0 means the first light, 1 means the second light, and so on. Okay, we press these buttons to turn on these indicator lights. That is something. Python, let's go, Python. Right or wrong? What? And okay, so we press these buttons. When you push a button, each indicator light listed on it gets on toggled. If it was off, and turns off if it was on. You have to push each button an integer number of times. Yes, that like yes. There is no such thing as 0.5 press, or nor can you press a button negative number of times. Yes. Yes, why would you? I think that might indicate which algorithm we can use. I don't know. So button wiring schematic like this means that each time you press that button, the first four, wait, the first, the fourth, and the fifth indicator light would all toggle. If the indicator lights were this, they would become like this, okay? Because none of the machines are running, the voltage requirements are irrelevant and can safely be ignored. You can push each button as many times as you like. However, to save on time, you will need to determine the fewest total presses required to correctly configure all indicator lights for all machines in your list. There are a few ways to correctly configure the first machine. For this one, you could press the first. Okay, let's see. We want second, like 1 and 2 to be on. We can turn on 2 directly from this. And for 1, we have 3 and 0 with it. Okay, we will have to turn off 3, which we can turn off. Wait, but for 1, with 1 we do not have 3. With 1 we have 3. Okay, so we can press this button, then press this button, then press this button, and we are good. You could press the first 3 buttons once, a total of 3 button presses. You could press 1 3 once, 2 3 once, and 0 1 twice, a total of 4 or 5. However, the fewest button presses required is to wait. We can do the whole thing in with 2 button presses. With 2 button presses. Wait, yep. 1 and 3 and 2 and 3. Cool. 2, 0, 2 and 0, 1. Yeah, same thing, same thing. 3 is the common one here, and in here, 0 is the common one. 0, 2, 0, 1. Okay. The second machine can be configured with at least 3 button presses. We want just this fourth one, and I think pressing a single button 2 times. Does it make sense to press a single button 2 times? And I also think that the order does not matter. The order of pushing these buttons does not matter. Here we were making pressing this thing twice. Yes, we were pressing this thing twice. Yeah, that does not matter. We can just skip pressing this twice. We can just press this and then this, and we are good. Yep, so we do not press any button more than once. Yep, it does not make sense. Either we press a button or we do not press a button. And also, yep, either we press a button or we do not press a button. That is the only thing. Yep, let's see. Let's see. The second machine can be configured with as few as 3 button presses. Right. And yes, when like if we make a multiset of all the buttons that we are pressing at the end, the indices which are appearing an even number of times will be off at the end, and the indices which are appearing an odd number of times will be there. So if we press 1 3 and 2 3, and if we make a multiset of this and this, we will have 1 there once, which is odd, so 1 will be on, and index 1 will be on, and 2 will also be on because 2 is here only once, and 3 would be off because 3 appears twice, and that is even. We can do something with that. One way to achieve this is by pressing the last 3 buttons like this. The third machine has something. Okay, the fewest presses required to correctly configure it is True. So the fused button required to configure the indicator lights on all of the machines is the sum. Analyze each machine's indicator light diagram, but wiring schematics. What is the fused button presses required to correctly configure the indicator lights on all of the machines? Hmm. Okay. Hello, that was it. Were you agree on okay JS? Uh, on FCKJS? Ah, okay, right. So, and let's also see how big the input is. We can brute force. I think you did brute force, right? You said in Discord brute force, and but the thing is, we can do brute force with each new button that we add. If we are representing buttons being pressed and not pressed by um, binary number, then for each button that we add, we have uh, twice the possibilities than the last one, right? And that is a lot. D10 text.txt, and there are 171 inputs. 171, right? And can we say, wait, can we use Vim to find out the maximum number of buttons? Let's say, what is the worst thing that we can prepare? There are 171 buttons. The 7 does not matter. There are 10 power 2 buttons. There are 10 power 2 buttons. And let's say we want our algorithm to run in 2 power 6. So, yes, to process one single machine, we can take maximum time as 10 power 4. 10 power 4 is 10,000. And 10,000, if we represent that as a power of 2 log to 10,000, well, 2 power 10, 2 power 13, I think would be 8088,000 something, and that is close enough. So at maximum, we can have 13 buttons. And do we ever have more than 13 buttons? We can manually look at it. I think we don't have 13 buttons, more than 13 buttons. So we can brute force, like your thing, we can brute force. Yeah, you can do for part one, but you have to some algo. Dar said, yeah, he said some heuristic thing. I don't know, some crazy heuristic thing. Okay, that would be obvious, right? To do this brute force. Can we think of a better way to do this? Wait, shit. I think I think there was a similar problem in code forces. So the main problem can be stated as this. We want a set of these buttons which results in this configuration. Then either we have one option, either and what is the requirement for the set of buttons that we are looking for? The requirement is that for the lights which are on, we want their count to be odd number of times in the union of all the buttons in our set. And for the lights that are off, we want their count to be an even number of times. So we have two options. Either we can start from an empty set and keep adding things as we need, or we can start with a full set, like take the union of the whole thing, and we can remove some elements. So we can, but the thing is, we want to get the best, the smallest number of sets. Wait, I think this is called bitmask DP. No, this is not called bitmask DP because these things are not interrelated. Uh, we are optimizing for the number of buttons. Well, since we can brute force, let's brute force. But you have to use some algo, which that is, yeah, that thing I also knew, but I cannot find a way to use it for implementation, the odd and even thing. Yep. What can we do with it? Let's at least write the brute force one. And Python for today. Python is cool. Uh, dot py. Let's go. Wait, there was something written. Shit, there was something written down there, but okay. Okay, Python is running. How to read Python dot read file maybe. Data equals IO OS, something like that. Open with open this file as read as file content equals file dot read. Yep. Okay. Uh, File equals open. Let's go. We are able to read the file, and that does not work. String has no attribute. Prim. I thought how to prim a string in Python. Strip dot strip dot split. Let's go. Object oriented. Yep, it is working. It is working. And okay, share this thing. The voltage is not even being used here. Okay, now we want to split this for row and data. Let's go. And let's say parts equals row dot split at spaces and split at spaces. And parsing in Python is something. Okay, so we share, we do not want to split at spaces, right? You want this thing to be one thing and then this thing to be one thing, or we can split for spaces and we can start indexing from one till the second last one. Yep, start indexing from one till the second last one. Yep, and yep, let's make parsing a separate thing. No need type annotation, file data, and a list of dictionary need the type annotation. Who needs type annotation? How do I say that this thing is going to be a list? Yep, it works. Wait, also pressing a button 2 times is the same. Yeah. Yeah. We either want the buttons to be on and off. That is why we need a set of those buttons. Like on off should be uh, odd and off should be 0 or even. 0 is also even, you can say. So either we press or we don't press. Yep. This is the only reason brute force works. But in part 2, you have to press a button multiple times. So brute force, wait, we have to press a button multiple times. That way you won't need to do file dot close. I will not do file dot close. Let's make it like um, vulnerability. Use regex shade. That is right. That is right. That is right. That is right. I can use regex on the string for parsing. Keyboard opens the file constantly, and soon the work is done. Automatically clears up the memory. Yeah, doesn't matter. Doesn't matter. We will write unsafe code, and yep, we will use regex. Cool. On this thing, so that we can get this part. This is going to be complicated, I guess. Wait, nope. We can like write the pattern for this thing inside a bracket, and then we can say this thing will appear one or multiple number of times. That will work. And one this at the start and one this at the end. Okay. Okay. And then getting data from the regex. Hmm. This is going to be regex. How to Python get matched parts. Yep, let's go 37-42 minute long video. Yep. Import re, then re dot this pattern. Look here. Okay, our pattern will have to be complicated. It scans the entire string for the first occurrence of pattern. We want there to be, wait, or we can, yeah, like since we have already splitted splitted this whole thing on spaces, we can just use regex for this part, right? For each of these parts. That is cool. That is cool. Okay, and for final data, yeah, and yes, I am here separating the process of parsing the data and then using the data, so that like for part 2 we don't have to make change in the part where we are parsing the data. Look up more look out more for memory with Python, especially because of the Python VM overhead and memory resources. And we are just doing add-on of code right now, so that is cool. uh, no worries here, but yeah, usually we should strip. Yep. Hmm. Or no, I think instead of even instead of using regex, just a split would work here. Yep, yep. And why does Python want me to do this? This is going to be a list of here, list of dictionary. Is that okay? And dictionary list of tuple. Is that cool? Invalid syntax. Okay, shape. Okay, this is not cool. Equals list of tuple. Why is this invalid syntax? A list of tuple or a list of list in Python. No, no, no. List. This is going to be a list of list. And yep, each list. Or maybe could even say tuple. Each record would be represented by a list or a tuple. A tuple is cool. A list of list. And then a list is empty. Yeah. A list of list. Yes. A two-dimensional list where each record is represented by a list. And in the inner list, the first thing is going to be the string, and then there is going to be a list of lists inside a single list, which is going to be the button. A two-dimensional list is going to be the second like parameter in the record list, and the last list is going to contain these junction points or whatever. Wait, these are 1 2 3 4, and here we have 1 2 6 buttons. So okay, final data dot split parts, right? And final dot append. Wait, no. Current is a list, and it is a list of lists. And current, the current data dot append parts 0 dot sub string. How do I get a sub string? Split line wise staircase. Substring in Python. Let's go string. Okay, string starting from index 1 till end minus 1. If that makes sense. Argument shared. Yep. Yep. First thing is a string. Okay, I guess I should write it like this. A record looks like this for like a single thing. Multi-line comments in Python. Uh, 3 things. A record looks like this. First, we have this string, which is like final light pattern. Then is going to be a list of numbers representing the buttons, and finally a list of numbers, the final voltage or something. So, and in this part, we are adding the string, the final light pattern, and now we have to iterate for I in range. Okay, initial, start, and step. Right, initial is 1. End would be parts dot length or length of parts minus 1. We have a button. Yep, buttons is a list of, yes, buttons is a list of lists which we will add to this. Yep. Currently, we are at a button. Yep. Button is a list of numbers, if we can say that. Numbers is not a thing. Buttons is a list. Okay. And for this list, wait, maybe we can even say button equals parts I starting from index 1 till -1 dot split and comma. That works. Split and comma. And is there a map function or something? Or like for each function? Python, there might be a for each function for list tuples. Okay. Uh, 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 def for each. No, no, there is not a for each function in Python. Hello, this might be the hardest day I have so far. Wait, hardest day in Advent of Code or hardest day period ever in life? 300 GB RAM. Pro has a lot of GB. Use this. Yes. Yep. Not this is not C++. It will be list of strings. Yep. But it is expected as well as only 3 days are left. Yep. Why are you creating lists again? After each iteration, the list is getting cleared, reassigned to be empty. There is a map filter function in Python inspired by FP something. Yep, list for each line, the current list. Wait, there is a map filter function. Map function and Python. Okay, there is a function. Map, run this function on this iterable. Okay, map. Okay, shade. You will have to give in the function as a lambda function. And this is how you write lambda function. And you can even call that lambda function in place. But the problem is this is C++. Some examples would be cool. Lambda input, do this. Okay, cool. Lambda takes in S, the current string, and parse int. How do I convert a string? Wait, just int. Do I have to return? I don't know. Okay, we have buttons dot append button argument 1. Wait, is this map creating a map? This button is supposed to be a list. Returns an iterator, so yes, this is a list. Buttons dot append argument 1 to append of list has incompatible type map of button instead of being a list of anything. It is a map of button. List, convert that into a list. Okay. Okay. We have the buttons, hopefully, and we can say current dot append. Okay, we have the buttons now for the voltage part. Yep. For voltage, we can just copy this. Voltage list of maps starting from this to this. Yep, and yeah, append voltage and not parts I, but parts minus one. Can we even print something like this? We can. Okay, that is crazy and does not make sense. Okay. Shit, because we are printing data. Let's print final data, which is empty, as expected. Shit. Final data dot append. Let's go. First thing is this, then a list of lists representing the buttons, and then a list which represents the voltage. Cool, cool. So we do have the data correctly. Right. Finding answer, finding Dory for record and final data. Yep. We do have the thing correctly. Use lambda keyword. Yep, it is there. Let's go. Bro actually knows before me writing what I'm going to write. Yes, there is a like a nice movie which I haven't seen. Durandar in the cinemas and yep. Record in final data. We have the record and we will use like brute force for the start. Hmm. Yep. Okay. The problem is I'm thinking C++ and this is not C++. Okay. Mm, mx equals the maximum number that our counter go to would be like here we have 6 buttons, so 2 power 6 plus 1 minus 1, 2 power 6 plus 1 7, 2 power 7 minus 1. Maximum number would be 2 power, wait, this is power in Python, 2 power record second length of this thing plus 1, and from this thing do minus 1. That is the maximum number. And how can we do pop count in this Python? Or is there a better, more compatible way of working with binary with Python? Map is generally used with lambda. Most of the time we used and throw function is used in it. Lol is helpful for taking multiple space separated inputs. If you don't know how many inputs they are, there are. Okay, we split and use map, I guess. Wait, what is UEO? That is something. Okay. How to work with binary in Python. Work with binary data. Yes. Yep. Yep. Binary when how to get pop count in Python for a number. Uh, bin, convert n into bin binary, I think, and then count the number of times that we have 1 in it. And the way of working with binary in Python is this. But I guess you can just work with normal numbers and in our minds think this number as a binary number. Okay. So while let's say I equals 0, which is also a solution for the times when no light is on. Yeah, I equals 0 is also the solution. And we will say, where is rest? Rest is above. Let's move down. C best, current best is infinity. Positive infinity in Python, or like a very big number in Python, float infinity. Right. Current best is this. While I is smaller than V, you can just say, yeah, while I is smaller than mx, and we don't have to do -1 in mx. Right. So I is a set. I is representing a set. Now we do have to go through, yeah, so we don't need the pop count actually, because we will go through I character by character or bit by bit. We will go through I. No idea what binary operation you want to use. I wanted to know pop count, like how many ones there are in a given number, right, in its binary representation. But we do not need that now, because I realized we will have to go through the number I. I here is representing a set of buttons, and we will have to go through each bit manually anyway, so we can just count whenever we see a 1 bit, right? Let's say count equals 0 and what the number of bits. Okay, I'm getting call. I'll pick up later. Wait. Yep. And count equals 0. Now for, let's say, b in range 0 till length of record, like how many bits there are going to be record 1 this thing plus 1 number of bits. There are this many number of bits. Yep, and b is pointing to a specific bit in the number I, right? And is bs, is b going through the thing like, wait, let me also make some change. Lol, I wasted my last 2 years in a language hoping so that I would be given. Let me change this, and this will say Python school. What? Language hopping. Okay, that makes sense. Yes, yes, bro does know a lot. Wasting is what I have done, knowing only two specific languages. That too, I didn't master much yet. Same. I think we are going through the range. Wait, I'll be right back in just 1 minute. Yep. Wait a minute. I'm back. That is cool. No, we aren't much different. Did I learn anything in depth? Shit, that is crazy. Uh, Wait, why does this sound a bit racist? We are not that different. I don't know a thing about it, bro. Yo, shit, that is a meme. Shit. Glazing. Okay. B is pointing to the current bit in I, and if one left shift, how to left or right shift? Uh, can we do binary shifts in Python? Yes, we can. Number and shift amount. Cool. Left shift 1 by B amount. If this number, take its and with I. If this number is true, if there is a number there, then shit, not just this. Shit. We have to see the buttons in this current, like the B index B buttons. Yep, in this, and take their and or do something about it. Or we can just actually toggle a thing. Yep. Light equals, how do I initialize a string? In Python for of a 13 size and give characters. Yep, shit, that's cool. Okay. String is this, and give me this how many times? Length of record 0. Right. And if this thing is 1, then go through this button for all the indices in this button, and for x in record buttons, the bth button, and if light at the location b, nope, for light at x is dot, then light at x becomes a hash, and else light at x becomes a dot. Right. Wait, unsupported target. No, x is strings are immutable in Python. Unsupported target for index argument. Shade strings are immutable in Python. Strings are immutable in Python. How to change one in a string in Python? I think, can we not do this? Yes, this is the new character and this location. Okay, that is very bad. That is literally very bad. Strings are immutable. We cannot change them. of the parser. Yo, hang on. Yo, hello. Uh, maybe, but it is actually a language to search it up. If you convert the string to a list, you can modify it. That is very straight. Yeah, that is cool. That is cool. So, like this. Wait, maybe no, no. There is a syntax for the list itself. I can say then this thing and a list of dots into len record 0. Let's go and no problem now. That is cool. And right, yep. After going through the current selection, yep. If convert into string before every live here, this thing should come here. If str light equals record 0 and not just this and this and shit. Yes, we also need a counter. Whenever we see this thing is true, we'll say cnt plus equals 1 and cnt smaller than current best. Yeah, just update the current best equals cnt. And after going through all the possible subsets I, we can say, and also shit I plus equals 1. Here we'll say best plus equals c best, which is apparently wrong because this is flow. Right? Uh, maximum and in Python maximum integer in Python sys dot max int, for which you will have to import sys. It's not very cool. Or instead of this, the worst answer. Okay, I'm getting a call now. Wait a minute. The worst answer would be len record 1. Like we are pressing all of the buttons. And hopefully that should have worked. Click out of range. Out of range. B is going out of range. Which is correct. Yep. And answer turns out to be 1229. But let's test for the test keys. Instead of file dot read string equals, let's say, file dot read, and here instead of this we'll say string equals the test case. Which is this, and paste, and I think, yeah, This is 15, and the correct answer is not 15, it is 7. So something went wrong. Foreign function interface, calling some other languages function in your own. I think there was a replace method too, maybe, or I am remembering. Yeah, too much language. Print final data, and final data is correct. And 654 is not correct. And I gotta put my phone on charge. 654. 654, I think we're pressing all of the buttons. Six, five buttons, and four buttons here. Yes, we are just adding up the number of buttons, which means we are not updating this thing. Okay. Yep. We are never getting into this thing. Okay. Let's. Oh, this might run quite a few times because this will run for each eye. Let's remove all the other records and we will only have one record. Okay, what does that mean? str. Wait, this is not getting converted into a string. Okay, list of char to string in Python. Join shared. Okay, empty thing dot join. Now we're getting this, and is there ever a pattern which is similar to this one? There must be. First one is like correct, yes, makes sense. And in the second one, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. Cool. The pattern. Yep, right here. This one is same. This one is same. And also this third last or this one. They are same. Okay, and so the problem was in this matching function. And let's go and yep. Yeah, that is good. Copy, paste, and answer turns out to be 7, which is the correct answer, right? Yes, 7 is the correct answer. So hopefully this thing is correct, and we don't want to print this 7 and not just 7. We will say final answer is final answer is 7. And comment this out, and final answer is 473. 473, and hopefully this is correct. Hopefully that is the correct answer. And just going over to the leaderboard. Yep. How are you checking all combos? Yes, reiterating I and going through everything. That is cool. I think there was a replacement. Number four. Okay. Ah, shit. I'm still not at the top, and I haven't done yesterday's question also completely. But no, shit, I'm at second. It, technically, kind of. Okay, on to the next part. Continue to part two. Okay, okay. Part two is long, but when part two is shorter, it is more scary. All of the machines are starting to come online. Now it is time to worry about the voltage requirements. Each machine needs to be configured to exactly the specified voltage levels to function properly. Below the buttons on each machine is a bigger level that you can use to switch the buttons from configuring the indicator lights to increasing the voltage levels. Ignore the indicator light diagrams. Wait, what? Each machine needs to be configured to exactly the specified voltage levels to function properly. Below the buttons on each machine is a bigger level that you can use to switch the buttons from configuring the indicator lights to increasing the voltage levels, and we can ignore the indicator lights. Okay, the machines each have a set of numeric counters tracking its voltage levels, one counter per voltage requirement. The counters are all initially set to 0. Okay, so the voltage requirements like this means that the machine has 4 counters which are initially set to 0, and the goal is to simultaneously configure the first counter to be 3, the second to be 5, and the third to be 4, and the seventh to be 4, and the fourth to be 7. The button wiring schematics are still relevant in this new voltage configuration mode. Each button now indicates which counters it affects, where 0 means the first counter, 1 means the first. Okay, and each list counter is increased by 1. When you push a button, each list counter is increased by 1. Okay, so a button wiring schematic like this means that each time you push that button, the counter number 1 and 3 increase by 1, and the second and fourth, yes, 1 and 3 means second and fourth will be increased by 1. If the current voltage levels were 1 in this, they would become 0 to 2 4, 0 to 2 4. You can push each button as many times as you like. However, your finger is getting sore from all the button pushing, and so you will need to determine the fewest total presses required to correctly configure each machine's voltage level counters to match the specified voltage requirements. Consider again the example from before. This thing, configuring the first machine's counter requires a minimum of 10 button presses. Hmm. 10 button presses. One way to do this is by pressing. Okay. We want to get, okay, we want to get there, and we have this. Let's think. Now we are at part 2. Wait, was this? Yeah, like second part to this statement, or you are saying yeah to something else? 10 plus 12. Okay, what is the fewest button presses required to correctly configure the voltage levels counters on all of the machines? It, I don't know why. It feels like uh, GCD, escalator font. This thing feels like GCD somehow. This is a button. This is a button. This is a button. This is a button, and this is what I want. What we want. Okay, what would be the uh uh right model to think about this? What would be a right model to think about this? Graphs? No. I, I don't know why. But yeah, we have to do something with sets. These are sets. And we cannot brute force. Yes, we cannot brute force. Brute force is quite dynamic. Yeah, I said to string matching issue. Okay. Yeah. Okay, shared. Yes, converting the thing into a join, I think. All combos. Just by like if there are four things, then I have a number mx which is 1 with 4 zeros and binary. Wait, shit. That number here I'm multiplying like 2 raised to the power of this, but that is kind of stupid. A better thing to do would be left shift 1 by this much amount to get the same answer. Yep, and I goes from 0 till smaller than this, which is 1, 1, 1, 1, 0. And each value of I represents one subset. Okay, for each configuration, the minimum isn't this similar to bit mask DP in some sense? I don't know. Can we say that uh, what is the best solution? Oh, no, there is no best solution. There is just one solution. Right? We want this. We want this. Okay, this is the constraint for the for the things that we are calling a solution, and optimizing a solution means reducing the number of buttons pressed. But there is also the fact if we like reduce this thing, right? If we say that we are just using 1 or 2 buttons, then we might never get to this solution. In which case we can say it takes an infinite number of clicks, right? And let's say we include, okay, can we do this in DP? You said dynamic. Can we do this in DP? But this is more like forcing DP onto this. Okay, let's think about this. Let's say there is some solution which has okay, let's see what the correct solution actually is. Correct solution, we want this. Okay, this button to be pressed 5 times. That is like for sure, right? No more or no less. because we want this number to be 5, and 5 is only appearing in this button, so yeah, 5 times. And after this number is 5, right? And 2, and all of these three numbers are also 5, right? 0 also appears in other places, so let's not think about 0. 3, we want 3 to be equal to 5, and it is appearing here and here, right? We want 3 to be 5, and shit, yes, we got this. We can press this button 5 times, and this button 0 times, and then this button 6 times, which is not a very good solution. Share, this is not a very good solution. We can press this button 5 times and this button 1 time, and this button 0 times. This is also a valid solution. We have 2 and 1 in all of these three buttons. 2 and 1 will have a value of 11. Total button presses are 11. And we have 0 in this button, and in this button we don't have 0 here. We don't have any other number here, so yep, 4 appears in both of these. So 4 will be 10, and 0 also appears in both of these, so 0 will be 10. That is cool. And 3 only appears in this, so 3 will be 5, and 5 only appears in this. 5 will be 5, and 11. So I think 11 is the best solution for this. Yep, 11 is the best solution for this. Can we now say what is the best solution if we exclude this button? No, there will not be a solution without this button. Yep, we can, this is the only this button right here. This one is the only button which we can remove while still having a solution. So I guess that approach in DP will not work, where we just say that we are using n of the starting buttons, because yeah, it does not match up here. And this is similar to the part 1. In part 1 we were trying to make some numbers appear like even number of times, and some number appear odd number of times. And here we don't want these numbers to appear even or odd number of times, so we want the numbers to appear exactly this number of times. So yeah, this does translate over from the other one. I don't think you can do, yes, same. I use a bit of math plus backtracking. Math, yep, math GCD or something, plus backtracking. Backtracking. And can a greedy algorithm work here? I think this is like coin change. Can a greedy algorithm work here? We will start with the button which has most number of, like, most number of things in it, and here that is this button and this button, and we will increase, like, yeah, we will press this button and we will simulate that thing, right? We will simulate that thing, and yeah, we can press this button 5 times, and the values, like these values that we end up with after pressing this button 5 times, would be 5, 5, 5, 5, and 5 is 0. 0, 1, 2, 3, 4, 5. For fifth, we have 0. But if we were to press this one more time, we cannot, because this 4 is the limiting thing. So yeah, if we press this button one more time, sixth time, then we are messed up. This 4, this will become 6, which is wrong. So yeah, back off, back tracking. Then we will go to the next button, which is the biggest button yet. Wait, this is 0, 1, 2, 3. Yes, 3 will become greater than it should be. Then we will keep pressing this button, and we can press this 5 times and we will get 10, 10, 10, 5, 10 and 5. And if we were to press this button one more time, we will add one more 5, we will get 6, and that is not very cool. So yeah, this thing. And then we will go to the next biggest button, which is this, and if we press this any number of times, it will increase 3, which is something that we do not want. So nope. Then we move on to this button. We can press this once and we can make these two numbers 11, 11, and we are good. But like, it does work in this case, but is it provably correct? Is this thing provably correct? We are always increasing, in this case, greedily, the maximum number of buttons that we can increase, right? So this would not be the this will not lead to the best optimal approach if we are saying that, let's say right now there is a very big button which increases a lot of knobs and things. Let's say it increases a lot of indices by 1, right? And then according to our algorithm will press this button if this is pressable, right? And let's say counteractively, there is an example in which pressing this button is not the best optimal choice, right? Okay, I'm trying. Okay, I think we can think of this in terms of bar graphs like this, right? Yep. So let's say we have a very big button which increases a lot of numbers. Let's say that big number increases this number, this number, this number, and this number. And currently their value is like some value. And we are saying that this button is pressable right now. So, which means we can increase all of these numbers by 1 and we won't have any problem. But this is saying that there is a better way to increase this. And that better way is pressing some other button. And since this button is the biggest right now, which is pressable, then that better, supposedly better way would include more than one button. And we would be in that case pressing two buttons, which is not as good as compared to pressing one button. But there is also the fact that we want the final values to exactly match up, right? So maybe if we do press the button right now, that would make having the final values as they are given impossible to have. That might be the case. Wait, but I think this is good because we are first of all making the choice which is least free. For example, here, if we have a button which just has a single character, this is most free, like free, like, yeah, we don't have any constraints with this. We can just this gives us a lot of fine-tuned control, and our algorithm goes from bulk control, where buttons have a lot of numbers, to buttons having fewer number of numbers. Let's implement this. I guess this might work. No, in part 1 we only press one time, so all combination can be checked. Yes, shit, my bad. Yep, not even and odd, but in a way, greedy might not work. Yeah, I'll have to see. Button can be pressed multiple times. Yep, greedy might, I don't know, might work, might not work. I think it might not work because not because of the fact that we are not optimizing for the coins. We will get the best number of coins, but the thing is we might not reach this exact final state of junctions that we want, right? That is one constraint that we want to have. And our greedy algorithm might not be looking out for this. Yes, it might just keep going on. Our Okay, for yes, there are two constraints, right? Exactly, there are two constraints. One is minimum number of coins, and the other is exact count. We need to have this exact count for all the junctions, and the other is we need this exact count with the minimum number of coins, wait, minimum number of clicks. Yeah, see, clicks. Greedy will take care of minimum. Right. Yeah, greedy will give us the minimum number of clicks, I think. But for we need this exact number of clicks. It might fail because in some cases we might want to increase the number of clicks in order to get this exact number of clicks. But the problem is I'm unable to think of a example in which what I'm saying would work, where greedy algorithm is giving us minimum number of clicks, but we are not getting the final exact amount. And there might come a point when we are unable to make any clicks. Yeah, when we cannot click any button and still we haven't reached this exact count. And that might be problematic. Let's implement this. P var2.py. Save. Remove this. And this thing can stay here, and tool path 2. For each record, here we are. Sort. We need to sort records. Buttons, and can you give a lambda function? A comma B, I think. And we did give a lambda function before for the map. Yes. So the syntax is this, and length of A is smaller than length of B. Undefined name sort. Okay. Sorting in Python's list dot sort, my list dot sort, key lambda. Key is lambda, I guess, to specify that we are giving a lambda function, and user dot a shade. No, this is okay. Shade. Okay, this whole thing is the lambda function. Okay. Record bracket one dot sort key equals lambda uh, button length of button. Okay, and this is in maximum reverse equals reversed equals true. How do I say reverse equals true? Yep. Sorted reverse equals true. We can say reverse equals true. Cool. And if we print record one, what do we see? We see error. Did you mean reverse? Yes, sir. Yep. Which yes, this is reversed max button which has maximum number of things in it. Okay. We don't need this. We can actually do this here, right here. Current buttons dot append before that buttons dot sort key equals lambda button length of button reverse equals true. Bye and cool. Okay. We have a set of buttons, right? So for button n record one, all the possible buttons, current, current, let's say voltage is this thing into, that is crazy, into length of record zero, or we could even say zero here, right? And now we need to see how many times can we press this current button. Y true. Let's see if we can press this button. Yeah. So for bn button, if 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 voltage b plus 1 makes this thing greater than record 2, which has the voltage is b, the voltage of this bth thing, then break. We cannot press this button any longer. We cannot press this button any longer. Shit, we will break out of this for loop, but not out of this outer while loop. Let's say P equals true, right? Yeah, P equals true, and before break, we'll say P equals false and break without the semicolon. And here, if not P or if not possible, then break, go out of this while loop. Otherwise, do not go out of this while loop and actually press this button for this once for B, or let's use a function. No, I do not want to use a function because we will have to take care of passing things by reference. Yeah, we can just say voltage of B increases by 1. And whenever we press a button, current equals 0. Incompatible types, who else has a thing? Okay, CURR was here, but the scope is different. Anyways, voltage increases by 1 whenever we press a button for plus equals 1. And that's plus equals. Wait, you said backtracking, but this is not backtracking. This is stupid, greedy algorithm. It's probably wrong. This is 32. I do not expect this to be, yeah. 9, 12, 11. 12, 11 is correct, but 9 is not. 9 is 9 is not correct. Yep, 9 is not correct. We can press all of these buttons and we need to get to this point. We need to get to this point. And you said math plus backtracking. And yes, you were correct. This implementation of greedy does not work. 3, 1, 3, 2, 3, 0, 2, 0, 1, 3, 5, 4, 7. 3, 1, 3. Okay, what does pressing a button mean? Pressing a button means we are increasing some values, only some values, some number of times. Yep, that is what pressing a button means. And pressing using the this greedy algorithm right now, we will never exceed the correct answer. We might not get the correct answer, but whatever number we do get, that will always be smaller than or equal to the correct answer. Yep. And after at the end, after pressing the buttons with a greedy algorithm, if we find out that at some point we messed up totally, then we have to move back. Backtracking. I've only done the place queens on n by n square using backtracking and nothing else. Backtracking means you make a choice. It is like DFS. You make a choice, you again make a choice, and if at some point you find out, shit, I messed up. Wait, maybe what is the maximum number of times that we are pressing a button ever? Let's see. Uh, don't print this. Don't even print the response. Here, say mx equals 0, and here mx equals maximum of mx, comma, comma, record 2. If that doesn't somehow works. UI and error. Line 36. Yeah, that does work. 12. 12 was the maximum. Was it the maximum? Yes, 12 was the maximum. Let's see what is the maximum in the input actual test case which has been given to us. 300. So if we go through with backtracking, then there are going to be at max 300 steps. But that means like whatever the okay, I'm thinking of this in this way. Like if we have 5 different buttons, button number 1, 2, 3, 4, 5, we can go through with one arbitrary random button. We can start going from this button, this button, this. Let's say we go through with this button, we update our list, and then again we have 5 different choices, and we will keep going through till at some point we see shit, we messed up. Then we will go on to some other solution, other button, and yeah, just like yeah, we'll keep doing this. And our whenever we see that our current solution is either at and after making after pressing any button, our list or our what do we call it, voltage, our voltage could either be smaller than the required voltage, in which case we move on to the next layer. Our voltage could be equal to the required voltage, in which case we see how deep the layer is and we update the best answer with the like depth of this layer. Or we could see that our current voltage for some value, maybe one or more values, is greater than the required voltage, in which case we backtrack, we go back. But this might be too much. This might be too much because we do know for a fact that for some answer, our maximum depth is going to be 300. That is just the maximum depth. And let's say we do go forward with 300 and there are this many records, and our maximum depth is 300, and let's say shed. No, that is too much. That is too much because at each depth we have, let's say even if we have like two buttons at each depth, then there are going to be 2 power 300 possibilities, and clearly this is not the right time complexity. But the thing is, we are not going to go through all of these possibilities. We will stop short for a lot of them before we ever reach a lot of them. Let's implement this backtracking, and then maybe we can, after implementing this brute force backtracking algorithm, we can optimize it in some ways. And one more thing that we would need to know is how to pass lists by reference in Python. How to pass lists by reference in Python. Okay, they are passed by reference, not a copy of them is passed. Okay, that is cool. Modify lists. Okay, that is cool. That is cool. That is cool. Lists are passed by reference. Backtrack. This takes in a list or current or join. This takes in a voltage and buttons. Right. And also the target. And how many buttons are pressed? Depth. Right. And if voltage equals target, voltage equals uh, let's even give them types. Voltage is a list of num. Buttons is a list of numbers, and target is a list of number, and depth is a number itself. Right. And what will this return? This will return a number. Right. And if these two are equal to each other, then return depth. What is a number? Number in Python. Python numbers. How do we specify numbers? Int. Wait, we say int. Substitute num with int. Okay, that is missing a return statement. Okay, that is cool. Right, right. So if not correct, then yeah, we will go through the buttons and see for button in buttons. For button in buttons, we will check can we press the button, the current button. Def is pressable. This takes in a button with a list of integers, a button, and target, which is a list of integers, and current voltage, which is also a list of integers. And this thing returns a bool type, return true at the end, and for b in button, if voltage b plus 1 becomes greater than target b, then return false. Current button is not pressable. So if is pressable, this button, and target is this, and voltage is this, if pressable. If this button is pressable, then press the button. Def press takes in a button, which is a list of integers and voltage. And for b in button, voltage b plus equals 1. Increase the voltage by this. Okay, if pressable, then press button with this less, with this voltage. This will, like, this algorithm that I'm implementing right now, this will work, but this might take too much time. Can there be a scenario where we press a button 80 times without exceeding the voltage value, but the best solution doesn't even include it? And it has the most buttons, so it seems out. Then will it try to check all combination from 80 times to 1 time? Right. Can there be a scenario where we press a button 80 times without exceeding the voltage value, but the best solution doesn't even include it? And it has the most buttons, so it seems obvious first choice. Then it will try to check all the combinations from 80 times to 1 time. I think I get this. You are saying what if there is a button which has a lot of numbers in it, and we press it 80 times, and it seems like the first obvious choice because it has a lot of buttons, but the best solution does not even include that button being pressed any number of times. Wait, this one, the backtracking one, will try to check all combinations from 80 times to 1 time. No, this will keep going on. And yes, I'm worried about the time complexity of this, which I think, and the camera is not working somehow. Wait, let me see. Wait, camera should be working. It is just not working somehow. Yep, let me just remove the camera in that case, which is much better. Yeah, is pressable, or we might even need a function like unpress a button, which is a list of integers, and voltage was also there, which was a list of integers also. For b and button, voltage b minus equals 1. Butto button, okay. And some water. Okay. For button and buttons, if pressable, then press the button. Okay, and after we have made this current choice, let's say, okay, I'm just like doing things badly now. Okay. Uh, yep. Uh, yeah, we'll call back track with this new voltage with these buttons as being the things that are pressed with this target and depth +1. And let's say best equals depth. Best is not depth. Best is not depth. Shit, best is literally not depth. Best float infinity. Best is infinity and best equals minimum of this thing the best. And okay, I thought I might get error because this backtrack function is returning an integer and best is not an integer, it is a float. But okay, automatic pressing, I guess. Okay, yeah, we make this choice. We explore all the possible scenarios after making this choice. Then we unpress this button and this voltage. This might like be very obviously wrong in some way, but I don't know. And return less. Incompatible. Okay, so now there is a problem when we are trying to return a float. Convert this into an integer, which might backfire. Let's, yeah, which might backfire. Test dot py. If we are doing, oh, wait. We don't need this. Test dot py. Yep. Python 3. Print integer format, the float int. Yep. Okay, what do we have? Huh? That is a full statement, so we should be seeing something. Print I. This was never. Okay, my bad. Yep, could not convert string to oh shit, it should be infinity. Uh, Float inf infinity. We see infinity. Can we convert infinity into integer? No, we cannot convert infinity to integer. Uh, Initialize int and to max value in Python. How to do that? System, nope. This dot max size. No. Maybe just saying instead of infinity here, maybe we can just give it a very big number like 2 billion to a 9. That is taking time, and that is not actually doing anything because we are not actually doing anything. Okay. Yep. For this current record. Yep. For this record, find the best solution, for which we'll say that the voltage is a list of 0 into record or length of record 0. And do we need anything else? Buttons? Yes, buttons. We do have buttons. Target, we do have target, and depth is initially equal to 0. Is it? Yes, it is. Okay. Okay, yes. Per equals backtrack voltage. Buttons are record value number 1, and then target is record value number 2, and depth initially is 0. Right, and rest plus equals current at the end, print answer is this. And yes, this makes sense. This just keeps on going on. Yep, keeps on going on. Okay, let's use the test case instead for this. And yeah, we will also see which record we are at. And I equals 1 and print record number I, and I plus equals 1. Right, we are not even at record number 1. Shit, maybe, just maybe, this thing never ends. This should end, though, right? This should end if current button is never pressable, then we are never doing anything. Press button for this voltage and then unpress the button. Hmm. Sorry. And the first argument is the voltage, then buttons, then target. Hmm. Hmm. Record number 1, and yeah. This thing is not stopping. Okay. Stuck as well. Yes. It, yeah, the camera. Okay. Hopefully the thing is good. Why wanted? Yes, that is a smart decision. I gave 2E9. Yeah, it doesn't matter. It is fine. 2E9 also works. Okay. Backtrack. The thing is, this is not working as expected. I expected this to like take a lot of time, but for the test case, this should have given the answer almost instantly. But this is not giving the answer almost instantly, shit, which might be correct. Okay, shit. Here in the first one, we have like 6 buttons, right? And the maximum depth of the layer is 7. So that is like 6 power 7. That is not a lot of steps. That is 200,000 steps. Not a lot. This should have worked. If we change this to have like some few, if we write a custom test, what about that? Like button 1 and 2. Yep, that is it. There are just two buttons, and here we will reduce this, and this becomes 0. This button is 1. There are just two buttons, and we want this one to appear like one time and this one to appear two times. Answer for this one should be 3, and this should not be very difficult for the algorithm to find. It is 3. That is cool. What if the answer is not possible? Like this, in this case, answer is not possible, and the answer turns out to be correct. Infinity, like the number which we are using to represent infinity. But when the number of buttons increases, we don't see anything. Let's increase the number of buttons gradually, right? And let's say we add one more button, and yeah, 2. And we want 2 to be there like 3 times. We still have the answer. What if we increase this to be 10? We still have, wait, yeah. The speed does require on how much we want the button to be, how many values, how much like we want the value here to be. And the maximum value is going to be 300, which we saw before. And we are facing problem at 100. So yes, we do have to optimize this. Even though this is correct, the backtracking algorithm is correct, but not very optimized. Not very optimized. We are literally going through every possible combination of pressing those buttons. Yeah. So at one layer we have, let's say, some choices of buttons we could press. We make one choice, we move forward, we make some choice. Will we, what we need is pruning. We need to cut off a lot of branches that are in this thing, and right now the only pruning process we have is here when we are checking if pressable. If the button is pressable, then press it, otherwise we won't press it, which is the least amount of pruning that we need and that we should be putting. We need more pruning, which means just removing some cases that we know are never the correct answer or the most optimal answer. And those would be the cases like if you already know the best solution to be some value, then we do not want to go deeper, right? Yeah, that would be something. Best is an integer. Don't return. Okay, do return this. And this thing gives wants us to give the best. Okay. Here the thing is that best. How do we check? Okay, if we do have a current working best at something. Hmm. 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 Yep. We will initially say that the best is 2e9. I don't, let's say 1e9. Huh. Expected int, convert this number into an integer. Right, this thing is cool. Before calling the back track again, we have to make a choice. We have to make a choice. Let's Yeah, our answer would never be 1e9. Okay, that is something. Yeah. Not in here. Okay, if best is smaller than 1e9, that means we already have a solution from somewhere else. We have a solution from somewhere else. If best is smaller than 1e9. Yep. And do we want to go one layer deeper? When we already have answer, do we want to go one layer deeper? Let's shade. Let's have best here 1e9, a global best, if you will, and it is not being passed from function to function, right? Yep. What is the wrong? Incompatible. 1e9 integer. Okay. Wait, in this case we don't even need this. Yeah, we don't even need to return. Yeah, just return, and function does not return anything. It will like null. And null does not exist in Python. Capital N. Okay, we won't say that this function is returning something. Right. If the current voltage and target are same, then return. Don't go any further, which makes sense. Yep. And if they are not small, which means we need to make some adjustment. We will only make adjustments here if if best. Okay, the best answer, if we do go one depth further, would be depth depth plus one would be the best answer, which means like we just have to make one more button press. Best depth plus one. If this answer is greater than best, right? This answer is like smaller than best. Only then try to press maximum of depth, comma best. Local variable, huh? Invalid syntax. How do I make a variable like available throughout a file? Global one, this is a global variable. Wait, it is accessible. At top level, they can be accessed from anywhere within that module, including inside functions. Uh, so this best should be available local variable before assignment. What does that even mean? Because we have best right here and we have best right here. Okay, let's say if depth is greater than or smaller than best, only then best equals depth. Shit. Okay, let's go. Minimum. Yes, we need minimum. Yeah, minimum of this plus depth. And whenever we increase the depth by one, we say so and space by and no. No success. No success. Shit. Wait, yep. I think the max button press should be not greater than the sum of joules. Wait, it will not be, yes, it will of course not be greater than the sum of joules, but it will not be greater than the maximum. Shit, no, I'm stupid. Yes, shit. Yes, 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 you are correct. You are correct. Shit, yes, you are correct. You are correct. What if each button only increases one value by one amount? In which case, yeah, we will be pressing each button this many times. Yes, 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 sure. And it will never be less than maximum joule value. Yes, yes, yes. Genius. X joules are this. And buttons are this is this. Example. Share. And buttons are this. Then we have to press yep. And if jolt is 3, 4, 5, and buttons are this, then we can press 3, 4, 5 times. Then the best is, yeah, 5. Yes, yes, my bad. Which means then that this algorithm is even worse than I thought. Yep, this is like, yeah, I'll have to think about this. What to do? Hmm. Maximum joltage. Joltage. And yep, I haven't even done the question from the second part from yesterday. That is also something. Shit. This thing, yep, second part from yesterday is also remaining. And 10th. Hmm. Yeah, I guess I will solve this at some later point. But yeah, I will solve this without using any chat GPT or anything. Yep. And I will take a walk now after 2 hours. Yep. And hmm, what can we do with this? Yeah, I'll take a walk and like think about this. No stress. It is cool. Are these machines all possible? Yes, that is also something I was thinking. But I think they are all possible, right? Because if they are not possible, then they have not specified what amount of button press we should take. And I guess in that case, they are possible. Like, yeah, the examples are given such that it is always possible to achieve this configuration. Because if it was not possible, then they would have said that use 0 or -1 or something in that case, if the configuration is not possible. Yep. No stress. You can just, yeah, I'll come back to this later. We'll think about this while a walk or bathing. And yep, that would be it for today. Yep, bro also thinks that. Yep. So these are possible always. And shit, my camera is not working, but that would be the end of today's stream. And thanks for being here. Shit, and I have not talked to you in a VC, and that would be nice to hear your voice. You have been here kind of like the longest, and you have been here like literally in all of the streams more than I have been here. So that is cool. Yep. Yeah, he is a genius. He's a genius. That's why he's a genius. And that will be the end of today's stream. And thank you for being here. And I would really like to hear your voice, Anshul Singh. And bye. Yep. Wait, not here. Here.